So here I'm recording the key takeaways for the CE 526 class. So first thing I want you to take away from the class is the idea of nominal safety versus substantive safety. In this class, we focused on substantive safety. The nominal safety is about whether or not you meet the design standards. If you meet the design standard, you're nominally safe. If you don't, then you're not. But in substantive safety, we look at safety in a spectrum. What kind of crashes are you experiencing? What kind of risk factors might be present? Okay? The other thing I want to talk about is how, or that I want you to take away, is how crashes are not accidents. You always think about crashes as events that could have been prevented. They're not some act of God or anything like that. And that is sort of the crashes not being accidents, sort of the guiding principle for Vision Zero. Because if crashes are not accidents, then we can do something about them. And that's how we get to having zero crashes on our roadways. And obviously it's an idealized vision, but it flows from the fact that crashes are preventable things. Okay, so make sure that you remember that crashes are not accidents. Use the term crashes or collisions rather than accidents. Okay, and then the other thing is that crashes could be caused by many different things. And sometimes they could go up or down just randomly as well, because there are few crashes. Crashes are in fact rare events in the context of the transportation system. But because they're rare events, they could go up or down on their own because of many factors or because of no reason whatsoever, right? So that's why what you need is the empirical Bayes approach that we talked about in the class. So for empirical Bayes approach, you use the crash data because the information on crash data is sort of the gold standard for assessing safety, gold standard to be able to assess safety. Now, when we do the safety, excuse me. So crash data is sort of the gold standard of being able to measure safety. But because crash data could go down on its own or up on its own, we have to combine the crash data from your own site that is just coming from one site from other reference sites that are similar to your site. And when we combine the two, we can get a better estimate of the combined of the safety of the location that you're dealing with. And that combined estimate that you get from the empirical Bayes method is very important because that can serve as a counterfactual if you made any improvement to your site and you did something else at that site now. That empirical Bayes estimate can serve as a counterfactual, and then you can compare what actually happened after your improvement to that counterfactual and be able to make a good, sound judgment about how effective your improvement really was, right? So that's another important thing. Why do we do empirical Bayes approach? Why do we have to go into all these SPFs and all that safety performance function stuff? The next thing I want you to take away, safety performance functions. They are negative binomial regression model that are provided from the highway safety manual. And we use negative binomial regression model because that's one part of, it's a regression model that you could use for count data. The data that is estimated or collected as counts typically can be modeled as a count of a certain events, right? And negative binomial regression model is a way to model that data. There is another sort of distribution, Poisson's distribution, that you could also use, but Poisson distribution is more restrictive in that it wants the mean and the standard deviation to be equal. But in negative binomial regression, you don't have that. You could have over dispersion in your data, and you don't have that restriction. And that's why the safety performance functions are essentially negative binomial regression models. So that's another thing. And we never want to, and what next takeaway is that we never want to do just a naive comparison. We never want to, if you make an improvement, maybe it could be a throwaway thing, but your decision-making cannot just be based on naive comparison of before and after crash data if you make an improvement. Because we have discussed in the class, there are a lot of problems associated with that, like regression to the mean, the changes in crash data because of other factors that you need to account for. So never do a naive comparison of before and after data to assess the effectiveness of the improvement that you made. I mentioned many times, the next takeaway is that I mentioned many times that you have crash data as the gold standard of measure of safety. Just because it's the gold standard, it doesn't mean it has no problems. There are several problems associated with relying just on crash data. One of those problems is that it's reactive in nature. You have to let all those crashes occur before you can make a determination. And that's why we need a more proactive approach. A more proactive approach could be a systemic safety approach, where it's proactive in nature in that it takes a look at the crash data-based evidence, but then figures out what the risk factors are that are causing those crashes. And then it looks for those same risk factors around the system. And that's when you improve. That's when you try to do the systemic safety. Systemic safety approach is becoming much more common. A lot of grant funding by state DOTs and federal DOT is being doled out based on systemic safety analysis. So it's very important that you're familiar with systemic safety approach and not just trying to treat hotspots where crashes have already occurred in a high amount. Okay, so you have to go beyond the hotspot analysis. Then another way of doing proactive safety is what you did in the road safety audit lab, just kind of going out to the field and looking at human factors and making, really, you are able to then recall the lessons that you learned in the human factors that we talked about, that how you have to make user the focal point, and then look at each roadway element from the perspective of a user so that you are able to see what safety problem might exist. So road safety audit is another way of looking at safety issues more proactively. And field observations are a little bit more based on engineering judgment. And then the last one, and you can then, those engineering judgment can then be combined with coming up with the solutions and looking up the crash modification factor from the federal CMF clearinghouse. And the last but not the least proactive measure is the surrogate measure-based approach that we talked about in this class through guest speakers from TransSoft Solution, as well as Dr. Amir Molan. And surrogate measures, you can make a more proactive safety assessment because you're not looking at crashes that are very rare, but even including near crash events or distribution of parameters that have impact on crashes, such as time to collision and post-encroachment time. And we can even now, as you saw in that TransSoft video, we can have video recording of real-world locations, and then we can derive these post-encroachment time and time to collision measures that can then be used to derive the surrogate safety measure for a real-world situation. And you could do this in a matter of days rather than waiting for multiple years of crashes to already occur. So those are my key takeaways, that you understand the difference between reactive and proactive safety. You realize that crashes and empirical Bayes method and why that is important. You understand the difference between nominal and substantive safety. You realize that the crashes are not accidents. And one thing that we talked about in this class was the programming. So I hope you got some exposure to programming as well. And next time you have to create some charts or do some data analysis, you would look beyond Excel a little bit and try to go into programming also. And but one thing is that, and I've provided that comment in a lot of report feedback, is that yes, programming is very important and you want to learn that. But when you're writing the report, just have a brief mention and never make programming or what program you use the focal point of your engineering report. Okay, so that's just tools should be just treated as tools and not be the centerpiece of your analysis. Okay, so that's all I wanted to say about the whole class, and I'll make this video recording available to you so you could refer back to it. So I'm going to go ahead and stop recording now.